Let's work on some examples for section 6.1 power series. So the first one we have is, I have a series that is the summation from n equal to 1 to infinity of x minus 3 to the nth power over n. I want to see for what kind of x values this series actually converge. So, in order for us to answer this question, we do need to actually check the convergence. So we have this series and then we have the powers here. Then it makes sense for us to use the ratio test. So we know that an is going to be the nth term, which is x minus 3 over n, to the nth power over n. And the an plus 1 is going to be the next term, which is going to be x minus 3 to the n plus 1 over n plus 1. So according to the ratio test, an plus 1 over an, the absolute value of this ratio, is going to be this thing over that one. But over meaning division, so they are fractions, so we can rewrite it as the regular form of the n plus 1 multiplied by the reciprocal of the an. And we can simplify them to get x minus 3 times n over n plus 1. I want to rewrite again by take out the x minus 3 and have the n over n plus 1, but I do not like the n over n plus 1, so I'm going to rewrite it one more time to get it as 1 over 1 plus 1 over n. Why I want to do that? Because as n goes to infinity, 1 over n is going to go to 0. Then 1 over 1 plus 1 over n will goes to 1. So that means invisible. So this one is going to be absolute value of x minus 1 as n goes to infinity. Then we know this is convergent. So the series is convergent when x minus 3 absolute value is less than 1, and divergent when x minus 3 greater than 1. We cannot say anything when they are equal to 1. And we are looking for the convergent piece. Now we can use some algebras. So convergent, that means x minus 3 less than 1. That means x minus 3 is going to be between -1 and 1. And x is going to be between 2 and 4. And that is going to be our intervals for the convergence. So the series converge when x is between 2 and 4.
2 plus 4 is 6.
Now we can looking at another example. This time, we're actually looking for the interval and the radius of convergence. So the series we have is summation n equal to 0, infinity, n factorial x to the nth power. For this one, we are still going to using the ratio test because of the x to the nth power. So we're going to take the limit as n goes to infinity of the n plus 1 factorial times x to the n plus 1 over n factorial times x to the n. Simplify them. N plus 1 factorial and n factorials, they will cancel out and just have n plus 1 on the top. And the x to the n plus 1 and x to the nth power, they will cancel out and just have the x on the top. Since we're talking about n, so we can put x out and just looking at the limit as n goes to infinity of the n plus 1, which is infinity. So absolute value of x times infinity, which is going to be infinity. Then from that portions, we know this one is going to be diverge. So therefore, the series diverge for all the x value as long as they are not equal to 0. Because of the setup, x to the nth power. So this one is centered at x equal to 0. Then it must be converged here. Then for this case, the interval of convergence is just a single value, x equal to 0, and then the radius of convergence, which is also going to be 0 because we only have one number. There's no radius or there's no intervals.